everyone. Thank you for coming for my talk, and thank you that you actually find it, because we swapped the talks with Tima. So this talk was scheduled for Friday. So if you're here, probably you're lucky you finally found it in the shuttle. So thank you very much for that. So my name is Anastasiia Kazakova. I worked for a company named JetBrains. We are doing tools for developers, IDEs, and team tools. But that won't be a product demo. If you're interested in our tools, we have a booth on the first floor today, and we'll have a booth on Wednesday and Thursday on the upper floors. Just come to us and we'll share all the information about our tools. That will be mostly the general talk. I will be showing some tools we do, but just as a part of the whole ecosystem. So just a few words about myself. So I used to say that I was a C++ developer, so for 8 years I was doing networking and embedded stuff, and then I moved to JetBrains, where I'm responsible for our C++ tools as a product marketing manager. And so I'm based in St. Petersburg in Russia. I run a C++ user group there, so if once you're around, you all are invited to join, and I will be happy to have you as our guests or speakers. So we have a very nice and welcoming community, so please join us. And this talk, it has this word debug in the name, but actually it's not about the debug in the classical sense. It's more about the code comprehension with the help of the tools and how we can unveil the code abstractions before even compiling the code. So let's see what we're going to cover today. So we'll first talk about the language and what is the problem, actually, which problem we're going to solve. And then we'll try to find out why the classical solution with just a debugger or static or dynamic analyzers doesn't work that good. And then we'll try to see how actually an IDE could help. And the IDE is like in a common sense here. So we'll be looking at some examples from Visual Studio, from C-Line, from Eclipse, many tools. So let's start from the first part. So C++. I would say that C++ still freaking out many developers in the world. And there are like a couple examples that reasonably show that. Like, for example, if you come to the game development and to the game developers, and you just ask them what language they use, which technology they use to code games, they would say that if they would like a game quickly and that's just an indie game, they will definitely take Unity and C#, because that's pretty easy and straightforward. You just put everything you have into one folder, and surprisingly, you get a game out of it, and you're done. If you're a AAA, if you're doing the games which actually are more complicated, that's definitely a C++. That's an Unreal Engine, or that's the custom C++ engines, which all these companies with the AAA marks, with the AAA games are doing. And that's really hard and complicated, and that's not like you can do a game in a day or two. That never happens, but you get more complicated and more profound games out of that. And they have this kind of feeling that C++ is for more profound people and more profound games out of that. Another story is about embedded, which is still mostly in C. With all our efforts to push embedded people to C++, we're still doing embedded in pure C. I was doing embedded for 5 years, writing like C with classes. In terms of that, I was just implementing these structures with the pointers to functions or whatever. I was trying to work around the C++. And there are reasons for that. Not only historical. And also there is an argument that actually still with all the C++ 17 and C++ 20 we are discussing here in the community, most of the developers are still using like C++ 11 or C++ 14. And let's try to find out what actually, why this probably happens and what's the reason here. So, and I have this nice quote from Björn, and he has a confirmation that he really said that on his site. There is a nice page on his site with this URL. And actually, the idea behind this quote is that, as Björn explained in his website, that actually that's true for all power languages, not only about the C++, because the power language actually it tries to protect you from simple dangers. But you know what happened next? We're running into more complicated, into harder problems. And that's what we have with the current trend in C++ when we try to come with more and more abstractions, which are really very powerful, but we're running into some harder issues with them because we're not prepared for that. And so this is probably the issue with the modern standards. So there is a nice trend started in C++ now that we try not only to make the C++ more powerful, but also more readable and simpler, which is really very good, because otherwise we will end up in the language which no one can adopt. But like some people think that there is no problem in that. Like we were running a booth at ACCU conference in Bristol in April this year, and the developers came to us and said like, but the developers should suffer. So they are feeling like it's fine that we have a complicated language and we have to struggle with that. And probably yes, because when we're like suffering, we're more thoughtful, we're trying to think about the code more and we're more accurate. But should really, like, could we overcome this difficulty with some tooling help? Maybe someone could help us not to struggle all the way along. I told you that actually due to many researches, the C++ 11 and C++ 14 are still the trending standards for most C++ developers in the world. And it actually has a couple of confirmations. So these are the information from our JetBrains developer ecosystem survey. So we run it quite widely. We started in 2017, then another one was in 2018. So you have two graphs here, the blue for the 17 year and the green for 18 year. And so in 17 year, we got not that many results for like C++, so there were only 1,700 developers, C++ developers who answered the survey. But in 2018, we got like 4,700. So it's nearly 5,000 for these replies. And you see what? So actually the thing is that like this is the top. And this is actually C++ 11 still. So there is an interesting movement still. So we also ask like if the people are moving to newest standards, and still the people are planning to move to the newest standards. And some are even planning to move to C++ 17. But we are way behind the like current modern standard in terms of the adoption. So we're still working with C++ 11. And actually many people are still working with C++ 98. So while we're here talking about the concepts and all the nice things around, the people are still writing their code in C++ 98. And here I would say that there are probably reasons for that. And the thing that actually a little bit freaks me out is that due to the same research, we got a number in 2018 that more than 40% of the developers are abandoning the unit testing frameworks. So they're trying to do their code with kind of complicated C++ language standard, not writing any unit tests at all. I'm feeling scared at this very point. I hope that there is some bug in the research in that point, really. I don't want to believe that story. Another survey actually run by the C++ Foundation, and they got like 3,200 answers for that. And you see nearly the same results. So there are like 98 C++ 11. So, and the modern standards are kind of not that widely adopted as the older one. So, and this cloud is actually very important because the C++ Foundation survey actually asked developers, participants to describe their difficulty with the language. So what's the issue with adopting the new standards? And you can see this like words like difficulty and difficult to understand, and the supporting compilers and tool chains, and some words like impossible and all the rest. So let's look at the real language example and try to get the idea what's actually happening there, why the modern abstractions can like be so scaring for the developers. So there is actually this example, and there is a nice story behind that example. So we got it while testing some new features in the IDE, and that was the example with which our QA engineer just came and said that, like, I see some issue with this code in the IDE, so we probably have a bug. And so from one point, it's kind of clear that there is a variable template here in this code, but the question from the developer was actually what this code is actually doing. Because it was clearly that we had some issue in the IDE with that code, but there were no clear understanding what actually happening behind this code in terms of why do we need this code, what's happening, what is it actually doing. So we try to, like, as all the developers nowadays, we try to gutball the code. Like, we put it to Compiler Explorer, we look at it with like Clang, we look at it with GCC. It doesn't provide us any reasonable and important information at this point, so it just like showed what it is, but it still doesn't answer the question, like, why do we need this code? And at this point, we started transforming the code and trying to simplify it. So first of all, like the first transformation, we just used another syntax. Then we actually removed the template, and in the end, we just removed the cast, and we end up in just a simple program returning 42. So all this complicated code, which we started with here, is just actually returning 42. And after that, we found an issue in the tool, we fixed that, everything was fine. But the idea behind the example is that in modern C++, we can actually write kind of very complicated code with some templates, variable templates, which has actually no big sense behind it, which just returns 42. So I could just write the simpler version of this code. It doesn't matter, so it's just the same. Another example here is that we have macros in C++ still. And Björn said in the morning that it spoils all the thing, and it spoils our like development and IDE and all the things like that. But we still have them. We still have to deal with them. And macros are probably bad, not because, like, in general they are fine, but it's bad because it's just a text substitution. And you can write whatever you want inside this macro. And if you look at the example, so you will see that I actually have some enum definition here, and it uses some just text file with some text here. So it's just an ill-formed code, it's just a text. And I'm undefining this X macro. And that means that after I actually do this undef, all the traces of what was happening actually there were removed. So I don't have any history left after that point, so because the macro was undefined. And I don't know the possible values for this enum. Like, I can guess, of course, I could read the macro and I could guess the possible values, but I don't see them like clearly because there is some file somewhere and some macro that did some processing with that. And of course, if my like tooling is smart enough, I could kind of generate these things, or a complete like code completion could work here. But in general, the idea is that we could define some things that are really hidden inside of this definition. And it's kind of complicated to get it out of this definition. Like another example with the macro is maybe not that crazy, but more regular one when I'm like using macro to like make a class definition, and there is some function inside this class, like function members. But the story is that I have no information about this class and its like function members at this point. So I have to look at how the macro looks like to understand that. So I have actually to get into this code properly. And that's kind of difficult because it could be located in some file, in some library, whatever. So I have to dig for it, I have to look for it, I have to find it, I have to get these values. Macros, yeah, that was about the macros. And now a little bit about the context and about the preprocessor. So here in this example, I actually have two files like foo.h and like this file, cpp file here. And you see that I have the X in both branches in my foo.h. And here is the template, and here is just an integer. So if you look at these points, so this part is actually either a template or an expression. And you know what? The actual thing is that it depends on this magic value. And this magic value can be taken from somewhere. So it might be a flag in the bolt system, like in the compiler flag, or it might be defined somewhere else in some library, which I could include in some way you know, the path to this magic could be really complicated, and this magic actually defines the meaning, the actual semantic of this code. So either it's a template or it's an expression, and it really matters. And even more complicated example comes when we are coming to these Metaclasses from Herb, because that is actually a nice idea, and this is just example from the Herb's proposal, which shows like that you have a shape interface and there is some meta class happening here, and in the end you get this shape struct. And what you see actually in your code, you see that you just wrote some interface and in the end you got some struct, but the question is how to understand which actual, like for example function members here you'll have in this shape struct. And you can't get it without actually reading this meta class. And you have to find it, and if it's like part of the meta standard library or whatever where it could be, you have to find it and you have to iterate for it and you have to get it to get the idea of what's going on there. And this is the point where I would call these meta classes professional hiders. So they're just professionally hiding the code from us and hiding the meaning of the code from us. Well, like, don't get me wrong, so they're good, like from my point of view, I like the idea, but like they're really hiding the code and we need some way to get it easily and to understand it easily. Overloads, like we can overload operators, we can overload functions, and when we are overloading the operators, the issue is that we can have just a plus operator or equality operator or whatever, and we never know if it's doing some kind of a regular thing we used to, so just like one integer plus another integer is just an addition, or is it doing something crazy and unpredictable. And there is no way to get that easily, so we have to find all the overloads and we have to find if that overloads fits into this particular case. And in like this line, half of these operators are like regular, just printing to the standard output, and half of them are kind of overloaded operator for my fraction class. And you know, they look the same. And that's the issue. So you never know. Function overloads, like you can get dozens of different functions spread around your code base in different libraries and whatever. And when you're actually calling a function, you have to find out all the options, all the overloads, and understand which particular overload was called. And like here in this code, like we could calculate and find out that the result will be, like the output will be 2 and 2. But to get that, you have to go through all the overloads and find the proper one for both cases. And it's not that complicated. There's kind of straightforward algorithm described in the standard. You can just go for it. But the idea is that you really have to build the whole overload set and then filter it properly. And like there are many ways how people try to deal with that, you know, trying to put some delete or whatever just to change the like privacy specifiers, to trying to dig into this code and trying to debug it properly. And there are actually more. So there are all these const expositories, there are injected code, there is reflection and these meta classes. And the story with the generated code and with the const export is that like no computational info is available after the point when the generated code is actually executed, and so the track is completely lost. And so that's an issue in terms of the history of the changes. Like, okay, so we have the regular debugger, we have the static and dynamic analyzers. Maybe we can deal with that in that point. So how the usual cycles for the program looks like, so we write the code, we compile it and link, and then we test and debug. And maybe that's enough. But the problem is that compilation could be, first of all, too long to wait. So maybe we don't want to like wait for that long. And sometimes we need some deployment process to like run some tests or run the application. And that also could take quite a long time. And we would like to understand the problem earlier. target platform might be different from the development platform, and that means that we really have to go to some other platform to run the application there to see what's happening. And moreover, the code base could be incomplete. We might be just like working on a library. So, and actually to run, so we need to run some tasks to make some usages of this library to actually see what's going on in the code. And also there might be just not a flow in logic, but maybe we just want to understand what's going on in the code just to understand it better, just to learn the code. And that doesn't mean that the code has an issue, which we could easily, like, for example, catch with some static analyzer. Maybe it's not, it's fine, it's a regular code, it's fine code, but we just want to get some knowledge out of this code. And that's about the transparency of the code and if we could actually understand it. So in that sense, this classical way not always get a result we want. So it not always like replies our questions. And actually this talk was honestly started, like the idea of this talk was started last year when the Herb Sutter was talking about the firsts on generative C++. And he started this idea that modern abstractions in the modern language are hiders. And that we needed tool support to help us with these hiders to unveil the actual meaning of the code. And there was the third that I really like is that the good abstractions do need to be toolable, which is like the nicest third for all the tool vendors because we all the way around we are like struggling with abstractions that are not toolable in a good way. And I'm happy that the standard committee have now the tooling evolution group where we could actually discuss these things with the committee, and that's really great. And like, yeah, this actual talk started with the Herb list, probably his like feature requests from Herb. And this is actually nice, so you could like see his suggestions on how to deal with abstractions from like C to like C++ 17 and even more. So, but let's actually see what we have and maybe dream about what we can actually have in the tools as well. So we'll start with the macros. So the goal of the macro debugging is to understand the substitution without even running the preprocessor. So we're in the IDE, not in the text editor. The text editor is good and quick, but it can't do that for you. An IDE is a smarter thing, and it can usually do some smart things for you. And what we would like to look at the code in the IDE and in some way to understand the substitution without like running the preprocessor. And so there are a couple of ways to do that in the modern tooling. So this is a screenshot from C-Line, and actually what it does, it shows you the final replacement for the macro in some tool window. It's called quick documentation. So, and you can actually call it on any macro and on the macro usage, and it will show you the final replacement, and you can actually try to understand what's going on there. And it's very handy when you have, for example, so like boost macros, which can be kind of complicated, and you would like to understand what's actually going on there in the very end when everything was substituted. So the separate tool window is good because there is no need for you to change the code. So you don't change the semantic, you don't like make any changes to your code. That's just a separate view which shows you what is going on there. The only thing is that maybe like not always you would like to see the final replacement, because like the final substitution might be really very big and complicated, and maybe you just want to understand what's going on next after like one step of substitution. And so this thing is available not only in C-Line, the Visual Studio with the latest update can do that as well. And this is the thing which we've implemented in ReSharper C++ when we actually taught ReSharper C++ to substitute just one next step. And that's the way of more or less debugging your macro. So you can just, unwind the stack in that sense, like if we talk about the macro substitution as a stack. So you can just unwind it one step back. So step by step, trying to understand what's going on in your code. So that's just a good way of learning what's actually happening in this macro. And you can actually stop at any point, deciding that that's enough, I understand what's going on further, and so just stop at this point and trying to read the code. So yeah, and actually you can just unwind it all to the end. So just substitute everything and get it in your code, the final substitution, not in a separate tool window, but just as a substitution here. There is one moment with which you have to be careful about the context. I will be back to it in a couple of minutes. So, and before that, just kind of practical example of this thing is when you're working with the boost macros and you would like to understand what this macro is actually doing, you can actually do step-by-step substitution or just come to the final substitution. And so you can come here, there are two ways, our step-by-step or just substitute everything until the end. And as I said, you have to be careful with the context. And let's assume we have this example. And this macro, actually, the problem is that I have this counter macro here. And if I go to and substitute the new var macro usage on a second line in my counter macro example function, so you see I got this substitution. And you see, actually, the tooling was showing me these red squiggles. And they were happening here because after I substituted the call, now the second new var, this new var macro is now creating the variable with the same name for me. And that's an issue. So you substituted something, and now the counter, or if you're using the line macro, which could also happen. So you just get the wrong value. You just change the semantic of your code after the substitution. So it's not correct anymore. It's not compilable like in this case, or you get some unpredictable results. And the story is that you can have this new var macro call in different places of your file or your code base, and you never know what's going on there. And if you substitute, you really have to be careful because you have to think about this change in the semantic thing. Okay, so a little bit more about the macros. So the macro debug is actually tricky not only because of the context, which I showed you before, but also because it's kind of complicated to get all the usages and to analyze all the usages. And the problem is, let's try to, for example, navigate to function declaration from this func here. And if you do, that's actually the result which you get in most of the modern tools. So you see that you'll get the declaration, and it goes to func declaration on the first line, the func declaration on the second line, and it will never actually show you this one, which also is an option here. Because to actually do the proper navigation, you have to analyze all the usages. So you have to dig for the whole code base and to find out all the places where you can actually use this func macro and try to navigate to them. But most of the tools don't do that. They try to limit the scope, otherwise you will be waiting for your navigation for ages. And this is kind of a balance between the very big code base and correctness. But when debugging a macro, you always have this kind of challenge. So if to do it the proper way, you have really to analyze everything. Now let's come to the type information debug. So the goal here is to understand the final type. And again, we don't want to compile the code or do something like that. So talking about understanding the final type. So in the modern C++, when we have all these games of auto and decal type, we can end up in the code which actually doesn't have any type in the visible part of the code. And the type here actually can be deduced from the actual usage. So you can get it, and it will be like a double type, or if you call the do operation from 3 and 0, you'll get the integer type. And the good story here is that since the IDE usually builds a full AST, the full syntax tree for a code, that means that it actually usually knows the type because it usually infers the type. And so most of the modern IDEs right now can do that. So there is a screenshot from C-Line, Eclipse, Visual Studio announced that as well recently. So they actually deducing the type, inferring the type and showing the inferred type in any kind of pop-up or dialog, which you could call. Okay, the next thing will be just trying to deal with the type def chain in the same way we deal with the macro chain. So there are actually a possibility in the modern tools to substitute type defs step by step, the same way as we did for the macros, and like unwind this kind of a stack like that. So there's the example with boost MPL, and let's assume I would like just to understand the type of the high variable. So, and I'm just substituting it step by step. This is how it works in ReSharper C++. And so in the end, I actually get this D type, or I can just simply call this substitute all the type defs until the very end and get it quicker. So you either take this path and go step by step, or you just take this path to go to the final result. And that's the same as it was for the macro. So you're just substituting it step by step, and you're trying to somehow debug it step by step and wind in the stack. A very interesting point about like meta information. Debugging meta information is it's tough, and I can't say that tools are ideal now with debugging the templates and all the meta information, but they are capable of doing some nice things. So first of all, there's the examples from like Develop, Eclipse, and ReSharper C++, which shows how you can actually try to understand which instantiation was actually used at the actual point of the template instantiation. So this screenshot from Develop actually is a very nice chain of instantiation which you can get there. So you can actually find, like on a template instantiation, you can call it and see what was the types used and how it was done, so it can build the whole chain of instantiation for you. Like Eclipse and ReSharper C++ just shows the function signature and also tries to show you the documentation, so that you can not only just check the function signature of the proper option that was used, but also to check some documentation if something reasonable is actually written there. So another example here, and this is more about the Dreamer slides. So that's the thing that I really would like to have in the tooling, but it's not yet there in the tools which at least I know about, but there were some attempts to do some interesting things. And the idea behind is that in this code, actually, I have a const expert. And like depending on the actual call, the const expert is calculated in different ways here. So I have different paths for first and for the second line. And I would really like my IDE to highlight it to me properly at this very point. So when I navigate from the actual usage, I would like to see which path is actually taken. That will be really good. There were some attempts to do something like that. Some, I guess, quite many years ago, the kdevelop can do some very interesting feature. It can navigate it from the template instantiation to the actual usage, and when you navigate to the from the usage to the template, you can inside the template you can actually see some Intellisense, some completion based on the original source from which you navigated. Unfortunately, kdevelop dropped this feature after moving to libclang. Just they didn't re-implement it on top of libclang, so it's no longer working in kdevelop. But it was really very nice, and I really like the idea, and I think that's what we definitely should do in the tools, because it will be really helpful. But there are actually some attempts to do something very similar, like template Intellisense done in the Visual Studio. Let's try to play the demo. So what they do is that actually in Visual Studio, you can, inside the template, you can get some help from the IDE if you explicitly tell the IDE which type you're gonna use while instantiating the template. After doing that, now you'll see that the code completion for this type will be available. So you see that the completion is now working, and it uses this type which I just explicitly tell the IDE that I will be using this type. So this is actually very nice. It helps us because most of the time, I guess, we're like instantiating template with some like more or less predefined set of types. We're not like using one template for everything. We're just using it for maybe like 3, 4, 5 types, more or less similar. So we can put it in that way. Now let's come to the overload debugging. So debugging functions and operators overload. And here our goal will be just to understand which particular overload was used. And that's the main question here. Let's first take a look at the operators. So for the operators, it's kind of complicated because like the standard operators are like overloaded in the libraries for many, many times. You get lots of options. What we tried to implement in C-line, we tried to make some kind of a highlighting. So you see that I actually have a caret here, and it highlights me my overload in the fraction class. And what we can do, we can actually search for usages. So I can put a caret on the like operator here and find usages, and it will be showing me the proper usages, including like the proper usages from this string. So you can actually highlight them, you can search for them, you can go to the declaration from the operator, in that way trying to understand if this operator is like overloaded. It's like it's always overloaded, but like if it's default overload or if it's some custom overload. And another like good question will be here to explain the overload resolution. As I said, overload resolution is not a very complicated process. It's just a set of rules which you have to follow to build the proper set. So to do the name lookup, like to do the template argument deduction, to like build this set, to pick up the proper candidate, and then just check some access control for that. That's good, but unfortunately the tools can't do a lot at this very point. So most of the modern tools right now can help you with showing the valuable overload set. So in Visual Studio, you can just list for these options. Maybe not that convenient that you have to list for them, but still you get all the options here. This is the C line. Well, you see in the parameter info all the options just listed in one list. And also Eclipse is doing nearly the same, but also just showing the full function signature, so you can get the whole understanding of the function. And like C# and C++ also adds a documentation to that, so you just see the whole function overload set with the documentation to that. And you can actually, like on our actual function call, you can look at this list and trying to guess what was the whole set and trying to understand what was actually selected. But I would really love that if the tools could show us some explanation, you know, like trying to explain to us why this particular candidate was selected. It's not a very intuitive thing, so I can't say that I have an idea how to implement it properly, how to show it properly, how to present it properly. So we are very open. If you have good ideas, share it with us. Maybe we can implement it. But that can be really handy in terms of understanding the overload set, because most of the tools right now, they just show the candidate set for you in this or that way. It's also handy, but maybe not enough. Talking about the overloads, actually there is this nice prototype. It's not a production code, but the idea here is that we can actually try and help you to navigate to similar functions. So when you're navigating to a function and the function signature doesn't match, actually the tool can try and do some guess and try to navigate you to a function that might be fitting your navigation purpose. So now let's talk a little bit about the includes and the header files and all the stuff. So the thing here is that there is this nice article from 2011, which I find very nice, and it's sharing the idea of like header hero. And the idea behind is that while we develop the project, while it lives more and more years and it goes through, the number of lines of code grows, and at the same time the number of include grows, because no one actually removes the includes most of the time. We're just adding new and new and never taking care about what's actually going on in many cases. And that means that actually this blow-up factor is dramatically changing, and the blow-up factor is like the total lines of code divided on the total lines of code parsed, while you, for example, are compiling the code or just doing something with it. And the thing is that with all this includes, the number of total lines parsed when you're, for example, doing a compilation, it's really huge, because you keep adding the includes, and most of them are probably not needed. And there are ways to deal with that. So the simplest idea that actually is coming to mind is precompiled headers. So you can just precompile something and just reduce the compilation time. But maybe the better approach will be to trying to find out if we really need that many header files and try to remove the unnecessary files. And there are a couple of options to do that. Like in ReSharper C++, the team implemented this includes profiler, and it's actually just trying to provide you the information about which header files are included and what is the total line numbers, like inclusive counters and just regular counter, so that you can actually sort by the files that are like having the most line contribution, and trying at least to look at these files and to understand if you really need all these includes in this file and why is it actually that big. But maybe even the better way will be to ask the tool to help to optimize the includes for you. And there is a very popular check in many IDEs which actually removes the unused includes. At least the IDE can try and highlight it to you. Yes?
Any of these tools help you create forward headers?
Yeah, that's actually a very good question. Let me just come to it in a minute. So, the first idea is just to highlight that some headers are unused. The second is a very popular tool, which is include what you use, and which can actually try to not only suggest that these includes are not necessary here, but also replace them with the forward declarations, exactly what you were asking. So there are some tools that are trying to do that. There's also an includator, which has a plugin for Eclipse CDT, so it works for Eclipse and Cvelop, which is based on Eclipse. And it also doing some very similar stuff. So these are actually kind of good tools. About the include what you use, at least what I know is that Google reported that they reduced the compilation time by 40% using that tool. And that's really huge. 40% is 1/3 of the compilation time reduced just because of using this kind of tools. So there are some tools doing like that, and you can actually try and use them. And I guess that's mostly it that I wanted to share with you here about the current state of the tools and how they deal with abstractions. There are a couple of useful links if you are interested in this nice blog post about the header here, or about all these surveys about the C++ ecosystem stuff. So there are more information about the most popular compiler use and build system use and whatever you could be interested in. And a very nice talk from Herb from last year CppCon keynotes about the efforts on generative C++. So that's it, and we have some time for the question. Thank you.
You had showed the auto variable of it deducing the type. Was that actually the compiler symbolic information that showed the deduced type? Or the compiler yet again inferred what it thought it was?
Yeah, so the question was about inferring the type if there is a compiler doing that. So in most IDEs, so they do that without a compiler help. So you don't need to compile your code to get this information, because most of the IDEs are building the AST, the syntax tree, and most of the IDEs are trying to infer the actual types of all the variables on the fly while you're typing the code to provide you the proper code completion and code navigation. So they don't rely on the compiler because the compilation could take a lot of time, and it can be maybe your code is still not compilable because you're still typing in the file. So the IDEs are dealing with the incorrect code, and so they're trying to infer the type on their own.
Well, I'm an engineer, so I don't trust the IDE to give you the right answer. So, where does the compiler, if that was in symbolic information, I could probably trust it better to tell me what it actually had compiled. I was just wondering.
I guess the question about trusting the IDE is mostly a question about the complexity of the code and if your IDE could do a good job for you or not. Yeah, more questions? Yeah.
I am kind of skeptical about doing this in the IDEs because, in my opinion, the real work should be done by the compiler and give you what are the choices that the compiler is using, because eventually you're going to have potentially optimizations, and the optimizations are going to lead to more discussion. So it is, in my opinion, the compiler the one that should give you the trace of what it's doing with your code. What do you think it should be done in the IDE? Because the IDE might not even implement the whole of the parsing of the language and the semantics and everything.
Yeah, that's actually a very good question. Is that why do we need an IDE doing this part of the job? Why we just couldn't force the compiler to provide a whole trace for us? I agree that the compiler could do a lot for us, but sometimes it's doing too much job at a time, so maybe I just need my compiler to compile my code and not to explain everything for me. Because the compilation is a longer process. It can be happening on not my local machine, it can be on my remote machine, it can require some bigger resources. And while working with the code in the IDE, I would like to get the understanding of the code right here and right now without waiting for maybe 2 hours of compilation on some remote host, without triggering some process, because sometimes the compilation means that you have first of all to generate some code because there might be some generation happening before the actual compilation, then to preload some libraries or whatever. So they might be a longer process, and while in the IDE, while typing the code, which might not be even compilable because I'm just in the process of typing, some implementation of the function or something, I still would like to understand the code better. I still would like to rely on some smartness happening for me, which actually shows me the meaning of these abstractions before I even compile the code. And in that sense, actually, the story is that IDE already doing part of this job, because to provide you code completion or code refactoring, they have to do that. They have to replicate part of the compiler job. It's different because they have different goals, you have to deal with the incorrect code, you have to deal with it quite quickly because you will never wait for completion for 2 hours. So it has to replicate the compiler job in some quicker way, so it has to do some lazy stuff and somehow deal with that. And since it's already doing that, why not ask the IDE to provide more smartness on top of that knowledge? Because it already has this knowledge. It has this AST and all the information around. So, and the only question here is that this balance between the performance and the actual features we can get. And I guess with the C++, most of the IDEs are usually struggling with this balance, and that's the major point why we still don't have all these, nice and shiny features for unveiling the abstractions. So hopefully that answers.
Yeah, thank you. A follow-up question. In Clang, for example, you can ask it to give you the complete set of compilation options that it used to generate an object file, and that's something you can inspect later. It's a JSON or data that you can process in your build system. Would it be good that the IDE can also generate a file, a JSON file, let's say, that you can use offline for all the analysis?
Probably that's a good idea, just to generate some output from IDE for the investigation. I never heard of that personally, because we used to do a lot of stuff inside the IDE, not sharing the results. But like, yeah, that's possible. You just need to understand the use case, how you're going to use that to request that from an IDE. Yeah. Yeah.
For debugging macros, it's easy enough to do that. You output the post-processed information. Is there any tool along that line you can test template expansion and see what is actually produced?
Yeah, that's actually a good question about the template expansion and any tests that help. I would say that this template instantiation thing, which the cvalp has now, is very nice, which shows you like the whole path of how the template was instantiated. So like, let me try to find the screenshot. It was, yeah, here. So like this is exactly it. So it can build the whole chain showing you how the templates was instantiated and which type were used. And it's kind of very handy. And that's probably the only tool I know that does that kind of thing.
Which one was that again?
It's cvalp. It's kind of an IDE built on top of Eclipse. Yeah, so Peter Sommerland is somewhere here around the venue. He's the major committer and the major person responsible for cvalp. So you can catch him with his red hat and ask. Yeah?
You can ask me as well. I'm part of the team that does that.
Yeah.
Perhaps to extend on that, the idea here is that you could further navigate from an instantiated template
Yeah,
what it
exactly.
uses, to other template instances, to actual functions as far as the IDE can resolve.
Yeah, so the longer chain doesn't fit the slide, but actually it can be quite a long chain of the template instantiation and go through this chain and understand the template instantiation step by step, which is kind of, very similar to like macro or type debugging step by step. Indeed.
But 10 times harder.
Yeah, 10 times harder, definitely. Yeah.
So I very much like the idea you mentioned about having some kind of way to see what was considered and discarded and why. Because my experience with this kind of code is that very often, if it either compiles as the wrong thing or doesn't compile at all, often you don't have a clue why your template wasn't matched.
Yeah.
And you may spend an hour or two trying to figure that out. The compiler knows, it's not telling you. And
Yeah, I guess
having a tool to tell you that would be very helpful.
I guess the worst thing is even when you have a compilable code, but you have some things happening in the code and that you don't understand why something is actually going wrong, and the reasons that, for example, the wrong overload for the function was selected, and you have to debug it in some way. You have to somehow find out what's going on here. So there are some things in the modern tooling that can help, and so we can try to do maybe more.
Yes, my experience is you end up putting in printf debugging, we're back to 1960.
Yeah, that's an issue actually. We always have an option to put some printing and debug some code. The thing is that sometimes, as I told already, so sometimes debugging could be painful because it can be many other aspects involved, and you can even hard to compile the code. So it would be good just to have some instruments to debug at least most of the cases before even compiling the code. Okay, more questions or comments? No? Okay, then thank you.